Hello everyone, I'm Raghu Chandra, currently presenting MIT's seminar on adversarial machine learning. We'll explore vulnerabilities and some of the differences in those AI models. With AI playing critical role in security-sensitive domains, understanding how models can be manipulated is essential for ensuring robust machine learning systems. So let's dive into the topic. Adversarial machine learning is a field that's focused on attacks that exploit weakness in AI models by crafting some deceptive inputs. These attacks can cause models to make incorrect predictions, leading to vulnerabilities in fraud detection, cybersecurity, and misinformation. Hmm. Why is it important today? As AI is deployed in critical areas like anomaly detectors, network setups, attackers are finding ways to manipulate these models for their benefit. And understanding these threats allow us to build stronger defenses in future. And these defenses might also help avoiding catastrophic impacts such as financial losses or some compromised security. So we have basically all these attacks can be classified into two types of attacks. One is exploratory attacks, where attackers analyze a model's behavior to understand its decision boundaries, and without modifying the training data, they alter the decision boundary according to the will by i- crafting some of the malicious in, changes in the input data. The second type of attack is causative attacks, where attackers manipulate training data to mislead the model into learning incorrect patterns. Attacks in detail. So, for example, exploratory attacks, also known as inference-based attacks, focus on understanding how AI model classifies the input without altering the training process. For example, attackers submit emails to the spam filters. For example, there is a free instead of free many, they just modify some of the characters in the free many to classify it as non-spam. The second example could be a version in image recognition, where a small interceptable noise is added to the image that can cause AI to misclassify it. For example, a minor pixel modification can make AI seem panda as gibbon. So these kind of attacks help adversaries craft inputs that evade detection while preserving the malicious intent. Also, coming to the causative attacks, where they manipulate mostly the training data by injecting or poisoning the input data or to the training data, and so that by finding some of the vulnerabilities in the data in the model. Main examples could be while in fraud detection, poisoning attackers inject fraudulent transactions into training data sets, teaching the systems that these behaviors are normal and make it harder for the models to detect it. And the second example is a backdoor attack in neural networks. A small trigger, such as a sticker on top of its stop sign, can make A classify it as a different object, leading to potentially security risks in autonomous driving systems. So, to understand these attacks better, I have done a case study on uh, evaluating one class SVM anomaly detector and also MPNet autoencoder to perform some adversarial attack using fake Amazon reviews. Like, we are classifying Amazon reviews as fake or not fake, whether it's generated either from GPT or from other sources. So the step-by-step process involves training one class SVM and MPNet encoder on normal Amazon reviews. So once we train them, we generate fake reviews using GPT-2 from one section of the reviews that we use of the normal reviews. Like, we use the first sentence of the reviews from the, like, for example, the review says the product is very good and it's very helpful. So we use the first few words and generate a fake review using GPT-2 model. And then later we modify, then we evaluate the performance of one class SVM and MPNet on these modified fake reviews. And then we modify and we get the whatever we identified it as fake reviews, and we get So we modify these reviews with glove embedding to make it harder to detect, then evaluate how many adversely modified reviews evade detection. So we identified those fake reviews, and then once we review those fake reviews, we try to make those fake reviews as genuine by modifying it using glove and testing it on one class SVM. This is our objective. So what uh, this final findings that I found is one initially one class SVM detected 17% of the fake reviews, and after some adversarial training, like once we generated fake reviews, we included some of those fake reviews to train the model. And after that robust training, it improved to only 19.5%. That small increase might be due to added vocabulary. MPNet autoencoder has a detection rate of 20.4. Like it detected 20.4% of the uh, fake reviews that were generated by GPT-2. So now we take some of the fake reviews generated from the 17.4 and 20.4, which were identified as fake by the generator. We're trying to modify it using glove. So once we try to modify it using glove, almost 50% of the modified fake reviews were evaded by these detectors by the previously set thresholds. This implies that when we modify few of the text or semantically similar meaning preserving words in a sentence, it almost evaded 50% of the time. This implies that we can fool the AI model by changing the input to that model and cheat the model in a way that uh, these can be hard to find. So the next steps are the what what could be done maybe to improve this. So we can train AI models with examples to we can include more adversarial examples to improve the resilience. We can try doing ensemble learning where we connect multiple models and average out, or we can connect take output from multiple models and then try to identify the misses. Next, we can try hybrid approaches. We can use combination of deep learning and linguistic analysis for anomaly detection for these type of attacks, but there might be some other methods for other type of attacks because it's mostly text in this case. And we can develop AI systems that can explain their predictions, making it easier to detect manipulation. Uh, So, what are the lessons learned from this experiment? Is AI models are vulnerable to small modifications. Even slight changes in input can cause models to misclassify anomalies. And adversarial attacks are practical and effective. Attackers can systematically evade AI models, causing real-world threats in fraud detection and cybersecurity. And also, the rise of AI generated contents with advancement in GPT-4 and some deepfake technology distinguishing between authentic and AI generated content is becoming much harder. And defense strategies must evolve. AI models must need adversarial training, consumer learning, and interoperability to enhance robustness. And trust in AI also depends on security of this model. So AI used in finance, healthcare, and security critical applications. So without proper defenses, adversarial attacks can undermine trust in AI-driven decisions. So to conclude, all of this adversarial attacks on machine learning models pose significant challenge to AI security, and exploratory and causative effects attacks can exploit vulnerabilities in machine learning models. And GPT-2 that I used in this experiment and Glove experiment demonstrated how easy is it to deceive anomaly detectors. And strong defenses are necessary to secure AI applications and build trust in their decisions. And this concludes our presentation. For further, if you have any further questions, you can post in the discussion chat. Thank you.